In this video, we discuss working with algebraic expressions and equations. An expression is a mathematical phrase made up of a sequence of mathematical symbols. Those symbols can be numbers, variables, or operations. In this example, we have an expression, 24 minus x, and we want to evaluate it when x equals 3. So what we do is we put 3 in wherever we see an x. So we go 24 minus 3, and then we use PEMDAS to simplify. So 24 minus 3 being 21. The same thing happens when we have multiple variables. So in this expression, we have L times W. So if we evaluate this when L is 3 and W is 8, we put in 3 for L and 8 for W, giving us 24. The next step is to be able to write our own algebraic expressions. So in example A here, we have a number increased by 5. So a number, it's an unknown number. So that's where we'll have a variable. Typically that variable will be x. So increased is addition, and it's being increased by 5. So we have our own expression here that we've created, x plus 5. In B, we have the product of 7 and a number. Again, that a number is unknown, so we'll have 7 times a variable, 7 times x, which we can write as 7x. In A, we have a number decreased by 30. So a number, that's our x, decrease is subtraction, so we're going to go x minus 30. The quotient of 20 and a number, quotient is division, a number is unknown, we'll have 20 over x. A number subtracted from 2, we're going to subtract our unknown x from 2. Here we have two operations, twice a number increased by 21. So twice a number, that's 2x, increased by 21 is plus 21. E, 5 times the difference of a number and 11. So it's 5 times the difference. So we have to construct the difference first. So it's the difference of a number and 11. So the difference of a number and 11 is x minus 11, and then it's 5 times that quantity. So how do we multiply the whole quantity here by 5? If I just put a 5 there, then I'm only multiplying the x by 5, so I have to put the entire difference in parentheses. The quotient of 10 times a number and 13, so it's the quotient of. So we have 10 times a number and 13 first. So we're going to have 10 times a number first. So we go 10 times x, and then it's the quotient of that to 13. So we have 10x over 13. Once we're comfortable writing our own expressions, then we can start to write our own equations, which we can then solve. So let's look at this example here. John is planning a rectangular garden that's 2 feet wide. He hasn't decided how long to make it, but he's considering 4, 5, and 6 feet. He wants to put a short fence around the garden. So using x to represent the length of the rectangular garden, he will need a couple of different possibilities, right? He'll need x plus 2 plus 2, right? For the garden. So it's 2 feet wide. Let's draw a picture here. So if it's 2 feet wide, but he hasn't decided how long to make it, we can call that x. So the length of the fencing, as we walk around the edge, we'll have a 2 plus another 2 plus 2 x's, right? So we have an x plus a 2 plus a 2, or 2x plus 4 feet of fencing. So what we can do is substitute in for x the various scenarios, right? So he hasn't decided how long to make it. He's considering 4 feet, 5 feet, and 6 feet. So we can take our expression and see what the 3 different scenarios require, right? So the expression is 2x plus 4. So if he decides on 4 feet for the length, we'll put 4 in for x. So we go 2 times 4 plus 4, that's 8 plus 4, that's 12. So he'll need 12 feet for the entire garden if he makes it 4 feet long. What if he makes it 5 feet long? So we go back to the expression 2x plus 4, and in place of x we put in a 5. So that'll be 10 plus 4, he'll need 14 feet. Okay, if he goes with 6 feet long, then it'll be 2x plus 4 again, but this time he'll be putting in 6 for x. So that'll be 12 plus 4, which is 16. So we have the 3 different scenarios. If he makes it 4 feet long, he'll need 12 feet of fencing. If he makes it 5 feet long, he'll need 14 feet. If he makes it 6 feet long, then he'll need 16 feet of fencing. In the next example, we have 10 increased by a number is 100. Find the number. So here we're going to have to write an equation and then solve the equation. So we have 10 increased by a number is, okay? So 10 increased by x is 100. So that gives us an equation we can solve. 10 plus x equals 100. So we isolate x, we move the 10 over. We have x equals 90. And that works out, right? 10 increased by 90 is 100. So we can check the answer very quickly and see that that works. Last 2 examples here. 4 times a number equals 24. So equals, it's clearly an equal sign. So 4 times a number, so a number is x. So we have 4 times x equals 24. We can divide both sides by 4 here. We get x equals 6. Five times the sum of a number and 7 is 267. So is our equals, so we have 267. So 5 times the sum, so we have the sum of a number and 7. So this will be a number x, our unknown, plus 7. And we need 5 times that quantity equals 267. So we're going to divide, to solve this, we distribute. So we have 5x plus 35 equaling 267. We move the 35 over. So we have 5x equals 232. We're going to divide both sides by the 5. And 232 isn't a multiple of 5, so we'll leave it as a fraction there. 232 over 5 as the answer.